In this video, I'm going over the Mach 1 review for the upcoming test for the geometry. So here in number 1, 2, and 3, this is going back to our parallel and perpendicular relationship. So remember, parallel, the slopes have to be the exact same, versus perpendicular has to be the opposite sign as well as reciprocal, so the negative reciprocal slopes. So which equation is parallel to here what's given? Well, first off, we have to make sure to solve for y. So divide by 6, because that's what's being multiplied. And y is equal to 3 over 6 is 1/2 x minus 4. So now looking to see with our slope of 1/2, that's why the answer is C, because the slopes are the same. Now in number 2, we're looking for perpendicular. Now notice here, we are going to have to get y by itself again. So subtract 4x from both sides. And now you have 12y is equal to 36 minus 4x. So now to get y by itself, because it's still being multiplied by 12, divide by 12. So now we have y is equal to 3, then minus 1/3 x, negative 4 over 12. So we have a slope of negative 1/3. What would be the negative reciprocal of negative 1/3? Positive 3, which is why the answer here is A. So now in number 3, again, looking for that relationship. So first solve for y and then divide by 8. So y is equal to, that is 2x minus 4. So right now we have a slope of positive 2 here. So now we need to look at the slope of the graph. Well, first off, notice, right, keep in mind direction. Our slope is negative. So right now we have a negative slope here. Then finding any 2 points on the line. So rise is 2, run is 1. 2 over 1, 2 over 1, which means our slope is negative 2. So what is the relationship between positive 2 and negative 2? Well, it's neither. They're just intersecting, not at a 90 degrees. So that's why this is a neither. Question 4 and 5, focusing on the distance and midpoint. So here, to find the distance between our 2 points, we need to find the difference. So like here between our x's, between 7 and negative 3, that gives you 10. So 10 squared. Then here, the distance between our y's, negative 2 minus 4, negative 6 squared. But then remember, right, no matter what, 2 negatives make a positive. And also using our distance formula in the end, taking that square root here. So really you have 100 plus 36, which gives you the distance of approximately, because then you can get the decimal, but of radical 136. So then to get the midpoint, remember now we are finding a new point. We're going to add our 2 x coordinates of 7 and negative 3 and then divide by 2 to find the halfway point. Negative 2 plus 4, right? Add the 2 y's. Divide by 2. So that's how you get a midpoint, because this is 4 over 2, which is 2, and 2 over 2, which gives you 1. So that is your midpoint. And number 5. Notice here you're looking for the length or the distance. Now this is given to you, the line here, so we could just straightforward, right, use Pythagorean theorem. So here my rise side is 4 and run side across is 8. So for our right triangle, we can use this to find distance. So 4 squared plus 8 squared is equal to c squared, like our ABC. Then here you've got, so 16 plus 64, which gives you 80. But again, always last step here, because notice we have c squared, take the square root. So c is approximately the value of radical 80. Then midpoint. The midpoint, now we need to make sure to identify our coordinates so we know what we're working with. So like here, we're at 6, 0, And over here on the left, we're at -2, -4. Now when adding the two x's, -2 plus 6, but then halfway point divide by 2. And then y's, -4 plus 0 divided by 2. So again here, that's how you got 4/2, which is 2, and -4/2, which is -2. So that is your midpoint, which makes sense. If I were to plot that, 2, -2 is right here, showing that midway point. So now in number 6, we're looking at this rectangle here, and we have AC. Notice how AC is this full diagonal, 15x plus 28. We're also given BD, which is the other full diagonal, 4x plus 61. Well, what do we remember about the diagonals in a rectangle? They're congruent. They are equal to each other. So that's how we can set up and solve for x. Now keep in mind, though, in the end, we're not just solving for x. We're looking for the length of AC. So once we get x, then make sure to plug it back in to solve for the length of AC. So here I'm going to gather my variables and subtract 4x from both sides. I'm sorry, not 19x, my fault. Here we have 11x plus 28 is equal to 61. Now we're just solving our two-step, right? Subtract 28, and that's how you end up with 33, and divide by 11. So x is equal to 3. But then again, right, this is not our answer. We're looking for the length of AC, which right now is 15x plus 28. And now we know the value of x, right? X is 3. So now we need to make sure and solve 15 times 3 plus 28, which gives you 45 plus 28. And that's why the length of AC here is 73. So in 7 and 8, continuing with the diagonals. Notice because here BD is 48, the full diagonal, and AC, the full diagonal, is 36. Well, there's a couple of things. What do we remember about the rhombus? Well, first off, clearly now they're not congruent to each other, right? The diagonals. One is 48, the other is 36. So they are not congruent to each other. However, they are perpendicular and they bisect each other. So if BD is 48, then that means BP is 24, as well as PD is 24, because it's cut in half. Same thing for AC. If it's being bisected and AC fully was 36, then that means each piece here is 18. Now we're looking for the perimeter, which means first we need one of the sides, because once we have one side, right, the rhombus, all sides are congruent, and we can find the perimeter. So again here, that's how we're going to use Pythagorean theorem. I've got 18 squared plus 24 squared is equal to x squared, or c squared. 18 squared plus 24 squared is equal to c squared. And then solving for c. So here we've got 324 plus 576, which gives you 900. And then again, always last step, right? With distance, take the square root. So see, that side length is 30. So if this side is 30, then all four sides are 30. So you could just add up all four, or just multiply by 4 to get you the perimeter of 120. Then for the square, we're given BD. This diagonal is 30. And that's it. We're looking for a side length, though, AD. So we are looking for this side length here, AD. That's our question. Now, we can find this, right? Because a few things about the diagonals in the square. Well, what's one? They are also perpendicular to each other, right? Creating a 90-degree angle. They also bisect each other. So in all of our special quadrilaterals, they're bisected. So BD is 30. That means BO is 15, as well as OD is also 15. We also know now that the diagonals are congruent to each other. So if BD is 30, then AC is also 30, which means these two pieces as well are 15. Now we can use Pythagorean theorem because of our right angle here. 15 squared plus 15 squared is equal to C squared. 15 squared plus 15 squared is equal to C squared. And now we can solve. So here you get 225, which gives you 450. But again, last step when finding distance, take the square root here. We have C squared, and C is going to be radical 450. Now in 9, 10, and 11, we're looking at our quadrilaterals here. So here, we need to identify the quadrilateral based on the properties. So I'm going to go ahead and label A, B, C, and D. So we'll focus on side AB first. Here, my rise and my run, right, to use Pythagorean theorem as well to find the length, which is 3 and 1. So I've got 3 squared plus 1 squared, but take the square root. So the length of AB is radical 10 here. Then the slope is positive rise over run, 3 over 1, which is 3. So now let's go to our next consecutive side. So BC, rise and run. Rise is 1, run is 3. 1 squared plus 3 squared, take the square root. Notice you end up with radical 10 again. And then the slope is still positive going up. Rise is 1, run of 3. So 1 over 3. So if you notice, the slopes, everything opposite is the same. So that means all sides are going to be radical 10. So we have a square or we have a rhombus. However, the slopes are not negative reciprocal, they're just reciprocal. So that's why here we have a rhombus. All sides are congruent at the length of radical 10, but no perpendicular angles. So then here in the other number 9 here, so I'm going to go ahead and erase this so I can do the next figure. Same thing, A, B, C, and D. We'll start with AB, and AB, rise and run. Now, notice, are we counting by 1 on the grid? No. Notice how we're counting by 2s. So be aware of that when you're looking at your grid here. So 2, 4, 6, 8 is the rise, and 2, 4 is the run. So this here, distance, is 8 squared plus 4 squared, and take the square root of that, which gives you radical 80. Then the slope is positive. Rise is 8 over run, which is 4. 8 over 4, well, 8 over 4 is 2. So now let's go to the next consecutive side here, BC. Again, rise and run. Notice your rise again, counting by 2s. 2, 4, run, 2, 4, 6. So here 4 squared plus 6 squared, and take the square root. So that's how you end up with radical 52. Then the slope. Now notice the direction is negative. So this is a negative slope. Rise is 4 over 6. So 4 over 6. Well, that can be simplified, right? Because they're both even. So dividing by 2, negative 2/3. Then as you continue, you will see that we have 8 over 4, which is opposite, parallel. and congruent, as well as 4 and 6 here, same thing. So here, not all sides are congruent. So we have a parallelogram or a rectangle. So here, do we have 90-degree angles? No, they are not negative reciprocal slopes. So that's why we have a parallelogram. Then question number 10. Question number 10 is going back to why we have a rectangle here. So again, focusing on sides, but also even the diagonals as well. Here I've got AB, so side AB, which rise and run. Again, notice it's not just 1, 2. You're counting by twos again. So 2, 4 over 2. So 4 squared plus 2 squared, take the square root, which here you get radical 20. Then the slope is rise positive 4 over 2, which is 2. Then going to the next consecutive side, BC. So BC is, rise is, well, that's just halfway, so that's just 1 over 2. So 1 squared plus 2 squared, take the square root, giving you radical 5. Then the slope. Now notice this is negative, rise is 1 over 2. So negative 1 over 2 or negative 1/2. Then as you continue, you will see that this again is also 4 because that's 2 here and then 1 and 1 more. So 4 and 2 and 1 and 2. So opposite sides are congruent, not all sides. And we have 90-degree. Yes, because you have the negative reciprocal slope. Then another, just to be sure, the diagonal. So now we're going to focus on the diagonal. BD. So BD, well here, that's just like accounting because it's a vertical line. So 2, 4, 5. So BD has a length of 5, but the slope, because it's vertical, is undefined. Then let's go to the other diagonal here, AC. Now here, we do need to get a rise and run. So I'm going to go ahead and erase my rise and run. So my rise here is 2, 3. My run is 2, 4. So here I've got 3 squared plus 4 squared, but take the square root, which ends up giving you 5, because this is radical 25, which is equal to 5. So notice the diagonals are congruent to each other. They are the same. And the slope is positive 3 over 4, which they're just intersecting. They're not 90-degree. So again, notice with our rectangle, we not only have the sides that are congruent to each other, opposite sides congruent and parallel, we also had the 90-degree angle from the negative reciprocal. And the diagonals. The diagonals are congruent to each other, but not perpendicular, proving that we have a rectangle.